Previously, we learned how to solve different types of trigonometric equations, and we said that the trig function plays the role of x or y, whatever the variable is. Now we are going to learn how to solve trig equation in which we use different identities. Let's have a look at this example. What do we notice here? We notice that there are two trig function, sine and cosine. What does that mean? It means that we have two different variables like x and y, and we cannot solve one equation with two different variables. So, we need to change one of them to the other. This could be done with the help of trig identities. So, we either convert cosine to an expression of sine or sine squared to an expression of cosine. We can replace sine squared with 1 minus cosine squared, which is an equivalent form of the Pythagorean identity. Doing so gives us this. Using distributive property gives us -1 plus cosine squared theta plus cosine theta is equal to 3. Subtracting 3 from both sides gives us this. This is a quadratic equation, so let's rewrite it in the standard form. How can we solve this quadratic trig equation? This quadratic equation can be solved by factoring. What is the factored form of this equation? We factor cosine squared theta into cosine, and we look for two numbers whose product is 2 and whose difference is 1. These numbers are -1 and +2. Setting each factor equal to 0, we get cosine theta is equal to +1 or cosine theta is equal to -2. What angle whose cosine is 1? The angle whose cosine is 1 must be quadrantal, which is 0. What angle whose cosine is -2? There is no angle whose cosine is -2, as the cosine of any angle ranges from -1 down to +1 up, so there is no solution for this part. Let's have a look at another example. We notice that there are two functions, sec and tan. To solve this equation, we need to convert one of them to the other. What identity can be used here? We can use the Pythagorean identity 1 plus tan squared instead of sec squared. Doing so gives us this equation whose only trig function is tan. Subtracting 1 from both sides gives us that. Setting it equal to 0 by subtracting 2 tan theta and 3 gives us that. Factoring this quadratic gives us tan theta minus 3 times tan theta plus 1. Setting each factor equal to 0, we get tan theta is equal to 3 or tan theta is equal to -1. These are the values of the trig function. But this is not enough, we need to find the values of angle theta. What angle whose tan is 3? The angle whose tan is 3 can be found using the calculator as 3 is not a tan of any special angle. So, we press Shift tan and then press equal to get the answer and press the comma button to change it to degrees if needed. The measure of angle theta is 1 degree 14 seconds and 57 minutes. This is the measure of the acute angle whose tan is +3. What do you think the other measure would be? Since tan is positive, the other measure must in quadrant 3, which is equal to 180 degrees, plus the acute angle. So, the angles whose tan is 3 are 1 degree, 14 seconds, 57 minutes and 181 degrees, 14 seconds, 57 minutes. Now, what acute angle whose tan is 1? The acute angle whose tan is 1 is 45 degrees. But tan is negative, so it exists in quadrant 2 and 4. What angles are the reflection of 45 degrees in quadrant 2 and quadrant 4? The reflection of angle 45 in quadrant 2 is 180 minus 45, and the reflection of 45 in quadrant 4 is 360 minus 45 or -45. In degrees, the two angles are 135 degrees and 315 degrees. To sum up, trig equation can be solved with one trig function. To solve trig equations with two trig function or more, we use trig identities to get it with one trig function. Remember, an angle in the second quadrant is equal to 180 minus the acute angle. An angle in the third quadrant is equal to 180 plus the acute angle. An angle in the fourth quadrant is equal to 360 minus the acute angle.